In this video, we're going to be taking a look at probability. We're going to learn to determine the probability of a specific event occurring. We're also going to look at what's called experimental probability, where we perform a specific experiment numerous times and then determine the probability of what would occur on the next attempt. So let's go ahead and take a look at some definitions. So here we have the definition of an experiment, and of course it's any activity in which results are observed. And then based on those observations, we have trials, and that's each individual observation. And of course, in an experiment, we have a specific result, and each result is called an outcome. We also have a sample space, and sample space is the set of all possible outcomes. Let's go ahead and take a look at some examples of experiments and sample spaces. So here you see an example of someone flipping a coin. The sample space is going to be heads or tails. A coin has two sides, so the sample space is one side and of course the other side. Here we have dice, or what may be called number cubes. If you were to roll a dice and it's six-sided with the numbers 1 through 6, then your sample space would be the numbers 1, 2, 3, 4, 5, or 6. These are your possible outcomes. And then in this example, we have a jar of marbles. They're colored marbles, so you could determine the probability of drawing a specific color depending on what is in the jar. It could be anywhere from blue to yellow. All the colors that are represented in the jar. Your colors are your outcomes or your sample space. A couple more definitions. An event is any set of one or more outcomes. And then the probability of an event, it's written capital P and then in parentheses the specific event. And it is a number from 0, which is 0%, to 1 or 100%. And that tells you how likely the event is to occur. So again, probability is represented as a percent, anywhere from 0 to 1 or 0% to 100%. Probability of 0 means that the event is impossible or it can never happen. If you have a jar of marbles and there's only red, green, and blue marbles, but you ask for the probability of drawing a purple, well, it's impossible, has a probability of 0. A probability of 1 means the event is certain, or it's a 100% probability. Again, if we have a jar of marbles and they're all red, and you were to ask what is the probability of drawing a red, well, it would be a 100% probability because it would be certain to draw a red because there would only be red marbles to draw. So, and then the probability of all the outcomes in the sample space add up to 1. Again, if you're looking at the different colored marbles, if you found the probability of the blue, the red, and the yellow, and that's all the colors there that were in the jar, then that would have to each individual probability for the different colors would have to add up to 100%. All right, let's take a look here at a practice problem. This one says, what is the probability of the spinner landing on red? Well, we have a spinner over here and we have a bunch of sections. We need to start by counting the sections. It looks like we have 6 on the top half and then 6. So there's a total of 12 sections. And then we're asked specifically about red. So we're going to need to count the red. And it looks like there are 5 red sections out of the 12. So we're going to write that probability as a fraction. And that fraction is the 5 out of 12. So there's 5/12 probability. We're going to go ahead and turn that into a percentage. We start by turning it into a decimal by dividing 12 into 5. 12 goes into 54 times. So you can see here that our decimal would be 0.416. Now, to turn that into a percentage is based on 100. So we're simply going to move the decimal over 2 places, and it would end up behind the 1. So we would have a 41.6% probability. 41.6%. Take a look at another example. It says, what is the probability of the spinner landing on blue? Same thing. We have the same amount of sections, but we are asking about blue. So we count the blue sections, and we see that there are a total of 3. So it would be 3 out of the 12. This is a fraction that can be reduced. 3/12 can be reduced to 1/4. And 1/4 is a fraction you should have memorized as a percentage. It is 1/4, or it is 25% probability of the spinner landing on blue. Okay, now let's take a look at experimental probability. Go ahead and read this. Experimental probability, the likelihood of an event is estimated by repeating an experiment many times and observing the number of times the event happens. Okay, so if we think about our spinner here, instead of determining the probability of it landing on orange if we spin one time, what we're going to do is we're going to have an experiment where we spin it, say, 50 times, and then we're going to record the different results. And then we'll find the probability of a specific color based on how many times that color occurred in the 50 spins. So if we were to write it as a fraction, 50 would be our total outcomes. And then we would say we recorded it, landed on orange 20 times. We would have a fraction of 20 out of 50. That would become 2/5. And 2/5 is a 40% probability. That's just kind of an example from a spinner based on spinning it 50 times. So again, experimental probability is when you actually perform or repeat an experiment many times. Let's go and look at some more examples. Okay, here we have a jar of marbles, and we are going to randomly draw from a jar and then replace the marble. And then we're going to record. You can see that this table shows the results after 50 draws. So we see that 20 times when we drew a blue marble, 12 times we drew a red, and then 18 times we drew a yellow. So it's a total of 50 times, and we're going to find the specific probability based on this experiment for blue. We'll go ahead and start with the blue. So we had 20 times out of 50. And of course, that's one we just did. That's 2/5, which equals 40%. So it's a 40% probability that it was going to be blue based on that experiment. Now let's go ahead and do the red. You can see that it was a red marble 12 times out of the 50. So this is a fraction. Let's go ahead and reduce it. Both numbers are even, so I usually just start by taking half of the number. Half of 12 is 6. Half of 50 is 25. They're no longer common factors, so 6/25 is reduced. We're going to turn that into a percentage by dividing 25 divided into 6. And you can see that our decimal is 0.24, or 24%. Now, the only other one that we have left is the yellow. And we could go ahead and find the probability, or we could simply add 40 and 24. And when we combine 40% and the 24% for the other colors, we end up with 64. Well, all three total would have to be 100%, so we could subtract 64 from 100, and you end up with 36. So 36% would be the yellow. So when you added 40%, 36%, and 24%, it all adds up to 100% based on the 50 draws of the marble. Now here we're going to take a look at some winning percentages, or the probability of winning based on different teams. The problem here says use the table to compare the probability that the Huskies will win their next game with the probability that the Knights will win their next game. So we're comparing these two teams, and we're going to determine who has the greater probability of winning. Now this is experimental probability because these teams have already played a certain number of games, and we have recorded their wins and their losses. And we're going to start by finding the winning probability, or the probability of winning the next game for the Huskies. So we're going to start with how many games they won, and it looks like the Huskies won 79 games out of 138. So that is currently the probability of winning the next game. We need to go ahead and divide to turn this into a percentage. 138 divided into 79. I know this is some of the math that we don't, that gives us a little bit of trouble. We wish we had a calculator, but we don't need a calculator. We can handle this. It says 138 into 790. I'm going to break it down into 100, and then we could call this 700, maybe 800. But so you could try 7 times. I think 7 would be a little too much because obviously 100 would go into 700, but then you have 38, and if you did that 7 times, you'd be way over 90. So I'm going to bring it down a little bit, and I'm going to start with actually 5. Let's start with 5 and see what happens. Yeah, I got 690, so we have a remainder of 100. I'm going to add a 0. Let's see, 138 goes into 1,000. I'm going to try 7 times. Let's see. Yeah, I got 966. We're going to have a remainder of 34. I'm going to go ahead and stop there. 0.57, usually if you carry out the decimal to the nearest hundredth, we'll call that 0.57 or 57%. So the Huskies have a 57% probability of winning their next game. And let's go ahead and compare those with the Knights have won 90 games out of 146. So we need to divide the 146 divided into 90. Let's see, 146 into 900. I'm going to start with, I think I'm going to start with 6. Got 876, so I have a remainder of 24. Go ahead and bring down a 0. And 146 only goes into 240 one time. So 0.61. I turn that into a decimal, again by moving the decimal 2 places to the right, which would be 61% probability of winning. So that you can see the Knights actually have the greater probability of winning their next game.
Made with Doodlecast Pro.